Friends, how are you? I hope you all are well. Today in this video, I am going to explain latent heat or specific latent heat. In previous class, I explained in my previous video the change of phase or change of state. During the change of state, we found there is no change in temperature. That means something was hidden. Today, I shall expose it in the form of latent heat, or you can say specific latent heat. So it is necessary to remind the change of phase or change of state. Normally a substance exists in three states. I am not discussing about the plasma state. I am saying about the solid state, liquid state and gaseous state. For example, in my last video I explained, suppose in this container ice is there. I am supplying heat. See here. Suppose in this container I have taken heat. I have taken solid ice which is the solid state. Now whenever I am supplying heat, for example, its temperature is minus 10 degrees Celsius. Now I supplied the heat. The temperature came to 0 degrees centigrade. I observed ice is there. Again, when I am continuously changing the temperature, I found, suppose continuously supplying the heat, I found still the temperature is 0 degree, and in the container I observed ice is there and water is there. Next, here also I found the temperature is 0 degree, only water is there. Again, next moment I observed that here water is there, but temperature is 10 degrees Celsius. That means I want to say that when ice converted into water, when temperature reached at 0 degrees Celsius, the ice started to melt. Ice started to melt into water. During its melting, it did not change its temperature. That means 0 degree centigrade ice is there, 0 degree Celsius also water is there. This is the transition temperature between ice and water. Now which temperature both can coexist. Similarly, if I continue this heating, water temperature increases. Again water reached at the 100 degrees Celsius. So again I am continuously supplying heat. Still its temperature is 100 degrees Celsius. In this 100 degrees Celsius water is there. At the same time we are observing that water is converting into vapor. That means until the conversion of water completely into vapor, there will be no change in temperature. The temperature is 100 degree. If the atmospheric pressure is at standard pressure, or you can say 1 atmosphere pressure. So during its change of phase or change of state, there is no change in temperature, or I can say that here the heat energy is externally not manifested. We are continuously supplying heat, but there is neither change in temperature. That means if I change the solid to liquid or liquid to solid, during that time neither there is a rise in temperature nor fall in temperature. Earlier classes in my video I explained that when ice is converting into water, that means solid is converting into liquid. During that time there is no change in temperature. So this is the ice. Suppose this is the water, this is the liquid state, this is the solid state. So during that time, ice absorb the heat energy. How much heat energy absorbed by the ice to convert into water? Same amount of heat energy released by the water to change it into ice state. So ice to water, we say that is melting. Water to ice, we say that is freezing or fusion. Okay. So during the freezing time, water releases the heat energy. During the melting time, ice absorbs the heat energy, but there is neither rise nor fall in temperature. Then where that heat gone? That heat only utilized to convert ice into water, to change solid phase to liquid phase. That means that heat is in hidden form. That's why we say that is latent heat. Latent means it is hidden. It is hidden. Similarly, if I supply the heat continuously from water to, we are getting the vapor, which is the gaseous state. During that time, water also absorbs the heat energy to change its state from liquid to vapor state. But there also will be no change in temperature. Similarly, if we come from vapor to water, that means we can say that is the condensation. Condensation. During that time, water vapor also releases the same amount of heat energy without changing the temperature. That means the heat is hidden form, that is the latent heat. Latent heat when expressed for unit mass of a substance. Now you see that, for example, you have a piece of ice which is 100 gram. Your friend having ice that is 500 gram. You want to change ice into water, he also wants to change ice into water. Definitely, both will require different amount of heat energy because your masses are different. For that purposes, to compare latent heat of this ice, that means how much heat is utilized to convert ice into water without the temperature, we have to consider the unit mass of the substance. That means if I consider 100 gram of ice to water by your friend, I have to consider here also 100 gram. If I consider 1 gram of ice converted into water by your friend, and I have to consider how much heat energy required by you to convert 1 gram of ice into water. So when the latent heat expressed for unit mass of the substance, we say that is specific latent heat. Both are same thing. Whenever you consider about the heat capacity and specific heat capacity, then you will feel what is the difference. Okay, so I can say that specific latent heat of a substance is the amount of energy or thermal energy or heat energy absorbed or released for unit mass of a substance to change its phase. So here I can write the specific latent heat of a substance. It is the specific latent heat of a substance is the amount of thermal energy, means heat energy, absorbed or released during its change of phase. PHAC, not my face. During change its change of phase means change of state at a constant temperature without changing the temperature. How much heat is absorbed or released during its change of phase, that is called the specific latent heat or latent heat. So mathematically I can say that latent heat is equal to Q upon M. Q is the amount of heat energy either absorbed or released, or I can say that heat energy exchanged for phase change divided by mass of the substance. This is the specific latent heat or latent heat. I can write its SI unit is joule per kg. We can express also kilo calorie per kg, or we can use calorie per gram also. So in SI system we use joule per kg as the unit of a SI unit of a specific latent heat. Again, the specific latent heat or latent heat divide into two categories. What is that? Here we studied three normal states. Generally we find the matter in three states. I am not saying about the 5 states. I am telling the general 3 states, what we say solid, liquid and gas. So whenever we are changing the substance from solid to liquid, there is no change in temperature. Similarly, when liquid to gaseous state we are changing, there is no change in temperature. So solid to liquid we say melting, or liquid to vapor we say that is freezing. In my previous video I explained and how the melting, boiling depends upon different factors like pressure also. I explained in my previous videos in the same topic. So during the change of solid to liquid, there will be a change in state, but there is no change in temperature externally. Okay, so that means here the heat is not manifested externally. Similarly, during the change from liquid to gas, there will be absorption of heat energy, or gas to liquid. So liquid to gas, we know it is called the vaporization. Okay, or gas to liquid, we say that is the condensation. Okay, so during condensation, same amount of heat is released. How much energy is absorbed during its vaporization? So latent heat again divided into two categories. One is the latent heat of fusion, one is the latent heat of vaporization. So in case of latent heat of fusion, I can say that amount of heat energy required by unit mass of a substance. Amount of heat energy required by unit mass of a substance to change its state from solid to liquid. And in case of latent heat of vaporization, I can say amount of heat energy required by unit mass of a substance to change its from liquid to gas without changing the temperature, that is called the latent heat of vaporization. So specific latent heat means amount of heat energy required to change its state from solid state to liquid or liquid state to gaseous. Solid state to liquid state, how much heat is required? That is the latent heat of fusion. Liquid state to vapor state, that is the latent heat of vaporization. So, when the latent heat expressed in unit mass, we say that is the specific latent heat. So, what about the specific latent heat of ice and water? So, now listen carefully. Suppose I am drawing a graph by taking heat in the x-axis and temperature in the y-axis. Okay? This is the case of the water. I shall get the graph like this. That means here to here, this is the solid phase. You can say this is the ice. So, in the previous example, when I said that when suppose the temperature of the ice is -10, now the temperature increasing. When the temperature reaches at 0 degree Celsius, ice started to convert into water. The process started. That process already I said this is the melting. So, during the melting there will be no rise in temperature, or you can say this is the change of phase. Solid is converting into water. Once it converted into water, again its temperature will not change until the water starts to boil, means evaporation starts in bulk. Okay, so here to here you find the solid phase, here this is the melting case, and here you find the only water, which is the liquid. Okay, once water temperature reached at 100 degrees Celsius, again the temperature will not increase until it is converting into vapor. So this is the solid, this is the melting process, this is the water, here to water to vapor, this is also change of phase. This is also change of phase. We say this is vaporization. So due to that, during the process, the liquid is converting into vapor. So this is the melting, this is the vaporization. The temperature at which vaporization takes place, I have mentioned here. This is the boiling point. This is the melting point. So this is the melting point. This is the boiling point at standard pressure. That means at 1 atmospheric pressure. So here this is, I have taken the ice. So latent heat of ice is, I can say that 80 kilocalories per kg. Here latent heat of vaporization is 540 kilocalories per kg, or you can write 80 calorie per gram or 540 calorie per kg. If I express in joule per kg, then I have to say that this is 3.33 into 10 to the power 5 joule per kg. This is the latent heat of a fusion. And in case of latent heat of vaporization, it is 22.6 into 10 to the power 5 joule per kg, or I have mentioned 540 kilocalories per kg or 540 calorie per gram. So this is the graph to explain you the latent heat of fusion as well as latent heat of vaporization. One small problem we see. energy is required to convert, how much heat energy required to convert 5 kg of ice into water. See that mathematically I said latent heat is equal to Q upon M, or I can say that this heat is equal to L into M. L is the latent heat or specific latent heat. Here the specific latent heat of ice is 336 joule per gram. So if I take here 336 joule per gram, mass how much I have taken? How much heat energy required to convert 5 kg of water? That means I have taken mass is 5000 gram. I have mentioned here 336 joule per gram. That's why I converted mass 5 kg into grams. So you will get it is 168 this much amount of a joule, or I can write 1.68 into 10 to the power 6 joule of heat energy. So I hope that you might have understood the video. So children, don't forget to share this video along with subscription, and like or dislike, it is up to you. So if you want to study continuously, consistently, you have to subscribe this channel. I hope. Thanks.